Okay guys, so I have just literally recorded like around 10 minutes and just realized I wasn't recording. So we're gonna start this once again. So that's a bad start already to the stream. So I scheduled the stream. So I thought maybe if I just click the stream option I'll actually stream, but that was not the case. But can you guys now see? Is it possible? Can you see the screen and can you hear me? Okay. So yeah, I scheduled the stream and apparently I forgot to go live in that page. I was going live somewhere else or something like that. So there's a bit of a confusion. But I think we should be okay now. Okay, we should be okay now. Okay, anyway, yeah, so what I was talking about was we have this question which is on calculations, right? And this question is rarely tested, first of all. Like when I was even trying to find this question, I had to go, it only appeared once in like the 2 years, in 2020, 2021. Okay. So yeah, that's that. So it's a quite rare question, but when it comes with around 3 marks, 4 marks, right? So yeah, anyway, we're going to do this question. We're going to do many other questions. We will do some other topics, and then also in the end we will do a summary. I believe your exam is on um Friday. Yeah. And yeah, someone is asking if I'm going to save this live. Yes, I will, so don't worry about that. I know it's a bit early. I was planning to do this live stream tomorrow, but again, if I do it tomorrow, right, then the doubt won't be cleared. It's better you fix all the mistakes you have right now, and then tomorrow you just keep doing past papers, right? This syllabus is quite easy. Even if you haven't revised, you can revise right now and you can still get an A star. So keep everything, keep focused, and then you'll do this. So anyway, we're gonna start with this question. Someone's asking if P1 is gonna be hard. Well, it depends on your revision, isn't it? If you have prepared for the hardest test, then you'll find it easy. But usually computer science is really easy. If you've seen my papers, my past paper videos, I usually finish them in 30 minutes. So like that's the case. So it's quite easy. It's usually straightforward questions, the same questions again and again. That's why you need to know your syllabus. Okay, so let's stop wasting time and let's actually begin. So here we have a question, and this question is about calculations. Okay, it's not the ordinary calculations. Now the calculations that always usually comes is a hexadecimal, binary, denary, but these types of questions is not as common. Okay, it's not as common, but they do come. As I was telling you guys previously, that I found this question, there was only one in the past 2 years, which you can tell there are not that many. Yeah, so that's what I was basically just trying to say. Okay, so now let's begin. It first starts by saying Georgia is a wedding photographer. Okay, these are usually irrelevant in almost all the questions. The first information is usually irrelevant, like it doesn't actually relate to the question, but it's good to read it, because you never know. Sometimes they can say give you answers in this, give you answers in that, and that's where they really trick you. So the first thing, it says she wants to show 10 photographs. Okay, that's a keyword right here, 10 photographs. Okay, 10 photographs. So don't calculate for one photograph. Sometimes many people just ignore that 10 photographs and calculate for one photograph. Okay, and it says each photograph is 100 pixels wide, 50 pixels high. Okay, the next thing, it is saying that these photographs are 8-bit color, right? And it says calculate the total size in kilobytes. Okay, and you can use this measurement. Now before we go to this question, before we're doing this question, let me tell you a simple trick on how to do this question. It's really easy. It's actually not that hard. Okay, all you need to remember first of all is the different conversions. Okay, we have, first of all, we have bits. From bits we have bytes. From bytes we have kilobytes, and then we have megabytes. Okay, so we have bits, bytes, kilobytes, and megabytes. Hopefully you can see yeah, you can see. Okay, so now this bits to bytes, how do you convert bits to bytes? Remember, 8 bits equals to 1 byte, so I would divide by 8 to find bytes. Then bytes to kilobytes, I would divide by 1024. Okay, and then again divide by 1024. Someone's asking if Boolean is in the syllabus. No, it was removed. You do not need to remember that anymore. If you guys don't know what Boolean is, it's basically in logic gates there is notation like X then on top and stuff like that, but that was removed from your syllabus, so that won't come. But you do need to know logic statements. Okay, I might cover it later on, later on and throughout this video, if that's a problem. All right, but we'll have a look at that. Okay, yes, logic statements but not Boolean. Okay, so yeah, so this is what you need to know. Okay, and usually they only ask you till megabytes, because after that dividing by 1024 is quite hard. Sometimes they tell you you can divide by 1000, which is also okay, right? And if they tell you, but if you're good at long division, use 1024. Okay, but you will not be undermarked if you use 1000. Okay, so yeah, with that being said, let's now attempt this question. The first things we need to do, we need to calculate the pixels, right, for one photograph. Okay, so let me erase this right now. Right, let me erase this, and let's calculate the pixels first. So we will do 100 times 50, right? So this will be 5000. Okay, 5000 pixels. Okay, now you need to also know the conversion between pixels, bits, bytes. Now to convert 5000 pixels into bits, you have to multiply by 8. Okay, but again, bits to bytes is divide by 8, so there's no point of doing that, but you can do that. I will show that in my steps right now. Okay, so 5000 times 8 will be 40,000, isn't it? So 40,000 bits. I divide this by 8 to get the bytes, which is, I believe, again back to 5000 bytes. Okay, that is 5000 bytes. Now we need to give in kilobytes. Okay, we need to give in kilobytes. Okay, so you need to know the conversion. After converting 5000 into bytes, now it will become easy. To convert to kilobytes, what do? You just multiply by 1000, or sorry, divide by 1000 in this case. Okay, because yeah, as I was previously talking about the different conversions, right? But this question is tricky. We'll do more of this right now. In just a minute, we'll do more of this. Okay, so now this 5000, we will divide this by 1000. Oh, sorry, 50,000, wasn't it? Oh wait, yeah, sorry. It's 10 photographs. So we shall do 5000 bytes times 10. Don't forget this times 10. You see, I almost forgot that. I just remembered it's 10. So this will become 50,000 bytes. Now to convert 50,000 bytes into kilobytes, we divide by 1000. So I will divide by 1000. These three go. The answer is 50 KB. Okay, now if you divide it by 1024, of course you will get, I think, maybe 48, 49. But even if you write 50 KB, that should be fine. Okay, that should be fine. Yes, calculators are not allowed, which is a tricky part. So you do need to learn how to do long division, but the safe side is you divide by 1000 so that you can, cancel out the zeros. That will be the safe side. But in the hexadecimal, binary, those ones, you have to do long division for some of them, which is a bit annoying, but I really don't know why they don't allow calculators. I think because some calculators can do conversions itself. So yeah, basically that's that. So the answer for this question is 50 KB. Let's do another question. Let me get another question. I don't know if you guys understood. So someone's saying to explain again. So it's easy. Look at this. Let me do it one more last time, right? First of all, calculate the pixels. They usually give you the width, the depth. Okay, so you do 100 times 50, which is 5000. This is 5000. This is in terms of pixels. To convert it to bits, you multiply it by 8. So that will be 40,000. 40,000 bits. But then to convert to bytes, we divide by 8. Okay, so that will be 5000 bytes. Yeah, good luck for all the people doing biology. I think it's in like some time, so good luck for that. Anyway, yeah, so that's bytes then, right? And then to convert the bytes, Remember, it's 10. It's 10. Where is it? Right here. 10 photographs. What we calculated was for one photograph. Okay, that's the reason why we have to multiply by 10. Okay, so this is only for one, because it says each photograph is 100 pixels wide, 50 pixels high. So right now what we have calculated is for one actual image. But if you don't understand, we'll do one more question. Don't worry, we will do more questions actually. If there's a particular question you want me to do, then you can ask me to. Okay, you can send me on Instagram or you can email me. I've given it in some of them. Someone's asking if we need to know DRAM and SRAM. So sometimes they do ask that actually. Okay, you need to know the different types of DVDs, CDs, RAMs and ROMs. Okay, but that's very unlikely they ask that. Okay, very unlikely. But it's, you know, it's always the safe side to actually know them, because sometimes these questions are really unpredictable. Okay, so let me remove this question. I'll try to find the other question that I have to find right now. Okay, so let me find it. I think there was another question on it was 2019 May June, so I'm going to go find that and then put it here. So it's another conversion question. Let's focus on conversion for a bit and then we'll have a look at it. Okay, let's do some conversion, because these questions are tricky sometimes. It's honestly tricky. Okay, but it's not that hard once when you understand, because they're the same thing, right? It's the same thing again and again. Let me just quickly copy this, 1 second. Give me a second. I find the question. So yeah, I found the question and let me paste it right here. So we do another question here. This is the question. Okay, this is the question. Let me enlarge it. Let's do this again. Okay, so let's do this question now. So here's another conversion question. Okay, if you missed the start, basically you need to just know how to convert from bits to bytes, bytes to kilobytes, kilobytes to megabytes. And if you missed that, don't worry, we'll do this question again, right? So Marley also needs to store a 10 8-bit color image. Remember, 10, again, they've mentioned how many. They want 10. Okay, don't ignore that. They want 10. And each image again is 500 pixels by 300 pixels. Calculate the total file size in megabytes. Okay, in megabytes. So let's first calculate in pixels. Okay, so 500 times 300. Okay, this is 15,000. This is 15,000 pixels. 15,000 pixels. Okay, to convert 15,000 pixels to bits, we multiply by 8 to give us this really value. I don't know, but yeah, this is not a necessary step. This step is not necessary, because in the next step you have to do 15,000 divided by 8, okay, to get something. So this is just cancelling out each other. Now the purpose for this is this one gets to bits, because pixels to bits is times 8, but then again bits to bytes is divided by 8. Okay, that is the difference. But if you want to multiply this, you can do 15 times 8 like this, 0 4 120. So this will be 120,000. Okay, yes, this is for Cambridge IGCSE. This question is rarely tested, but it comes, so you need to know how to do the conversions. So this is 120,000, but when I divide by 8, I get back to 15,000. Okay, you'll get back to 15,000. So now we have 15,000. Remember, 15,000 is for one photograph. You multiply that by 10. Okay, you multiply that by 10. Okay, so you will have, I think, 150,000. Okay, now this 150,000 is in bytes. How do you convert to megabytes? Remember, it's bytes to kilobytes to megabytes. So do we need to learn about No, you don't. That one rarely tested, not tested actually. I haven't seen any question in that, so I don't think you need to know that. Okay? Do not think you need to know that. Okay, so yeah, that is that. Let's continue again. So where was I? Let me just clear this mess again, start a bit fresh. So we found the bits, wasn't it? Or did we find the bytes? Okay, I'm kind of lost here. Forgot what I did. Okay, yeah. Oh yeah, I remember. Okay, so yeah. So we said we do 500 times 300 times 10, isn't it, for all the photographs. Okay, and that will give us one of the values. Okay, 10 8-bit color images in a file for each project. So that will give us, if we multiply all this together, that's 6 zeros, isn't it? So that's 1.5 million. And then to convert to megabytes, you divide by 1000 and then you divide it again by 1000. So these zeros all cancel and you will be left with 1.5 MB. Okay, do you guys understand that? I just have a feeling like 5 zeros. Yeah, do I do that again? Yeah, let's do that again. I'll repeat what I just did. It's a bit confusing, but the steps is easy, right? Okay, first of all, the first step, I'm gonna break it down easy now because I think some people don't really understand this. Okay, first step you want to do, they usually give you the pixels, isn't it? So the first step you want to do is to multiply these two pixels together. Okay, so let's just multiply that. So 500 times 300 is what? 15 0 0 0 0. There you go, 150,000. This 150,000 is in pixels. Okay, or pixels are just bytes. Okay, so I'm gonna ignore that step below. Okay, but for the sake of getting those 3 marks, sometimes you might have made a mistake on the way, so it's important to actually do the steps. So this is the first step. Hopefully everyone understands till there. Okay, hopefully everyone understands there. I will do some others. If you can send me, you can. That would be much better because I think I have to find more because they rarely come. But yeah, let's do this again because it's almost the same thing again and again. So this 150,000 pixels, you will multiply it by 8 to get bits. You will then divide it by 8 to get bytes. Okay. Yes, exactly. 500 will give you 150,000 like here. Then this is for one photo. So 150,000 will be multiplied by 10 to get 1.5 million. Okay, and then you divide this by 1000 to get kilobytes and then another 1000. So this 3 zeros, and then they all cancel. And then the last zero will become 1.5. So that's 1.5 MB. Okay. So that should be fine. You do need to remember long division also for the exam because you're not allowed calculators. Okay, let me try find another question. If you guys find a question, put the year down below so I can do that same question. Okay, put that year down below. But yeah, while you guys find that, let's do a question on SSD and HDD because someone I think requested that. Okay, let's do that question. So we have done 2 conversion questions, not enough, but it's almost the same thing again and again. So there's a question right here, May-June 2021, May-June 2021, paper 1-3. So we're gonna pick that one right now. And there's a question on how HDD stores data. You need to know how HDD stores data. You also need to know how SSD stores data. Okay, you need to know the 3 of them, or the 2 of them, sorry. Okay, so let me quickly paste it here. I'm doing this all by myself, that's why I think sorry for the delay. Right here, done. So this is the question. This is an easier question. This one's all theory. Okay, this one is all theory. Okay, so here's HDD. First thing you need to know, HDD has moving parts. I think that itself just gives you a mark there. HDD has moving parts, will give you a mark. Always know, okay, always know that there's HDD, there's SSD, okay, and then there's USB. Okay, usually if they give you the difference between the three, they either first thing ask you, does it have moving parts? Okay, you need to remember that HDD has moving parts. Okay, HDD has moving parts. This one has moving parts. Okay, SSD does not have moving parts, but it uses a different type of technology. Okay, it uses a different type of technology. Okay, we move on. Now, how would you describe this? First thing, so it's 4 marks right here. So first step I would say, okay, let me write it here. Hopefully there was no question for the conversion ones. Okay, yeah, so someone else has given another question. We'll have a look at this after this question, if that's fine. 2017. Okay, I'll have a look at that. Just let me do this one first. Okay, hopefully that's fine. So we look at HDD and SSD, and then we'll go back to conversions, because I think that's a bit more tricky. That's what I've seen, that people are struggling a bit in that. So no worries. Okay, so anyway, let's go. The first step, you need to know that it has moving parts. Okay, even if that gives you a mark or doesn't give you a mark, just say it has moving parts. Now, so it says it has moving parts. Now these moving parts are called disks. Okay, disks move in concentric tracks, or can just say it moves in track. Okay, and is spun. Okay, and is spun. So what the HDD works is that it has a track around the disk, and it basically is spun round and round, and that means it has moving parts. It has a read-write arm that moves this across the disk. Okay, and how does it read the data? Okay, how does it read the data? It uses electromagnets. Uses electromagnets. This type of stuff you just need to know, isn't it? This type of stuff you just need to know. $500 times 300 is not yeah, it is 150,000. Yeah, it is. I did correct myself, didn't I? Yeah. And then that 15,000, the 150,000, you have to multiply it by 10 to get your the thing for all the 10 files, and then you divide by 1,000, then you divide again by 1,000. I explained that in the start of the stream if you don't understand. I think if you can play back the stream, you'll understand that. Okay, you just need to know the conversions between bits to bytes to kilobytes to megabytes. Okay, for those questions. Okay, so yeah, HDD, it has moving parts. The disks move in a track, and it's spun. It uses electromagnets, okay, which are read-write data using electromagnets. You can also mention that it has a read-write arm. Okay, read-write arm. Okay, and finally uses magnetic fields. Okay, so whenever you're talking about HDD, you need to know these first 5 steps. First steps has moving parts, which are called platters. Okay, or they're basically moving tracks. Second thing, it's spun. Okay, spun, moving parts. Let me have a look at that. Moving parts, spun. Talk about electromagnets. Okay, talk about electromagnets. Talk about read-write arm. Okay, read-write arm, and then use of magnetic fields. Those are the only ones you need to know. Okay, can we write that it stores data on the magnetic surfaces of the platters? Yes, it does. Yes, it does. Okay, so how it reads is with the help of the read-write data, and that read-write data uses electromagnets. So these electromagnets and the electromagnetic field will help determine the binary value. Okay, try to memorize the marking scheme definition, because in computer science, that's the main trick. You need to know the marking scheme definition, and it's usually almost in every subject actually, but in computer science it's just repeated. Okay, can I show the marking scheme? Okay, I'll have to find the marking scheme. 1 second. Will I do that? Okay. Okay, give me a second. I think it was 2021, wasn't it? Yeah, let me find it. Okay. The marking scheme just says this. Yeah, I've found the marking scheme, and let me do another one. Give me a second. Okay, let me paste it now. Okay, let me delete this, and then let me upload this. And then after this, we'll do the conversion question once again, because I think that one still people are struggling a bit. So this is what the marking scheme says. Right here. Okay, this is what the marking scheme says. So it says it has platters. The platters are divided into tracks. Okay, the disk is spun. It has a read-write arm. It uses electromagnets, only electromagnets. Okay, with SSD, it uses something called NAND technology, and it flashes that memory and then converts it to binary and stuff. Okay, do you need to learn OLEDs? No, you don't. In the syllabus, it is only LED and it's LCD. It's a bit outdated, but those are the only ones you need to know. The syllabus is outdated. They should actually make people learn OLED. There's actually so many types, right? There's QLED, OLED, so many others. I don't even know. They should update this syllabus, but yeah, it is what it is. But you only need to know QLED. You only need to know LED and LCD. Okay, so there was a question that I was told to do. 2017. I'm going to find it 1 second. 2017. So this one, I believe, was another conversion question, but let's see. So 2017, paper 1-3, October, November. Let me have a look at this. If you have any questions, just put it on the chat. I'll try my best. Okay, someone's asked, what questions do you think come most often, or what most probably will come in the exam? Like I've seen a 6-mark question on sensors in almost every paper. Anything else? Now, the first thing you need to know, usually on the first page, there's usually conversions. Okay, so you need to keep that into mind. There is usually conversion. So in conversions, you need to know how to convert binary to denary to hexadecimal. That is really easy. That's 3 marks according to me. That is 3 marks. Okay, that is 3 marks. Okay, question 9 was it? Yeah, so that one is 3 marks. Okay, so here we have a small short 2-mark question, but yeah, so that one is 3 marks. Another one that always comes is logic gates. Always comes either in either they tell you to name the logic gate, either they give you the logic circuit and you're supposed to draw, or you could also be told to do the usual truth table and all sorts of stuff like that. So that one is also quite popular. I'm trying to think of something else. Also, you need to know about data transmission, serial data transmission, parallel data transmission. That is also quite common. Okay, that one is also quite common. Okay, so they really talk about serial data transmission, stuff like that. Another thing that's common, input output devices. You need to know each of the definitions for those. Okay, those are usually the ones that always come. Then there's of course topics like conversions, that sometimes it comes. There's topics like translators and stuff like that, compilers, assemblers. Then there's sometimes topics like freeware, shareware can come. So it depends, right? It depends. It really depends. But I think conversions for sure will come. You need to learn your conversions. But I think conversions is easy, isn't it? Right? Conversions should be straightforward. But if you have any problem for conversions, like maybe sometimes people struggle with binary to denary, but it's not really that hard. Yeah, it's not really that hard. So here we have a question on conversions. I was given this on the chat, so I'll do this quickly. If you find any other particular question, you can put it on the chat, like with the year and the question, like what this person has done, and I'll try to do this. Okay. This one is which question is this? It was October, November, paper 1-3. Someone's asking, what about data transmission errors? Yeah, that can also that one can come. Yeah, so that one sometimes it depends on which one they pick. Like sometimes they can bring ARQ, sometimes checksum. So my advice to you is to go through all of that. But for computer science, you just need to know the theory. It's so like straightforward. Like it's either you know or you don't know. It's a type of question, like it's a type of paper like that. So if you're prepared, you'll do well. So don't worry about that. Okay. So let's do this question. It says Camille wants to store a 16-bit image file. The image size is 1000 pixels. Okay, so this time we don't even need to calculate the pixels because they have given you the pixels. It says calculate the size of file, give you answer in bytes, sorry. Now this is a 16-bit color image file. Okay. That means if I multiply 16 times 1000, this will give me, is it 16,000? Yes, 16,000. This is 16,000 bits. Okay. Is that okay for now? This one's a really easy question actually. If it's a 16-bit color image, that means that one pixel is 16 bits. So 1000 times 16 will give us 16,000 bits. And then to convert it to bytes, we said you divide by 8. So to divide by 8, I think is 2000. Yes, 2000 bytes. Simple, straightforward. The answer is 2000 bytes. Okay, so this one was a more straightforward question. If there's any other particular question, let me know. Okay, let me know. Okay, some people told me to go over input and output devices, so I'll have a look at that. Okay, input and output devices. They might be really common, but you need to really know about like the basics. Sometimes the basics is the one that really makes you get low marks. Like sometimes people ignore conversions. Okay, and then in the end of the exam, okay, let's do conversions. Let's do conversions because conversions will for sure come. I guarantee that it will come. Okay, what are the conversions you need to know? Okay, we have binary going to denary going to hexadecimal. Okay, so we have binary going to denary going to hexadecimal. You need to know the conversions between binary to denary, the conversions between denary to hexadecimal, then hexadecimal to denary, then denary to binary. Then of course we have binary to hexadecimal and hexadecimal to binary. Okay, so this diagram is quite bad, but this is the main idea, isn't it, that you need to know. So let's start off with binary to denary. Now let me tell you the trick to this question, or the trick to this, right? Let me tell you what you need to remember. Remember this. So what you need to know is this thing right here. So 2 to the power 0. 2 to the power 1, right? 2 to the power 2, 2 to the power 3, 2 to the power 4. These are all base 2, isn't it? Base 2, base 2, base 2, base 2. This is 1, 2, 4, 8, 16, 32, 64, 128. You need to remember this. Now, what the trick is, they've told you, they've given you to convert maybe let's say 124 into binary. 124, you need to comprise it with this. Okay, so you'll need 64. So 64 plus 32 will be 9. So you'll need 96. Then 96 plus 16 will be 11, is it? Yeah, 11. So you need this. Then you will need, what else would you need? You would need 8 and you need 4, and the rest are all 0. I don't know if you understand what I did, but it's quite straightforward because you have to make 124 from these numbers. That's the main trick. And then when you know how to convert from maybe binary to denary, then if you understand denary to hexadecimal, it's quite easy. Okay, now someone has told me to do a particular type of question, so let's do that question. I think conversions are quite straightforward, isn't it? Conversions should be good, right? Because we've done so many. In every past paper I've done conversions. But if you still have problems, I made a video on it. I know the audio quality is bad for that. It was my first video, so quality was really bad. But then in many past paper questions, I've done that. So someone is telling me to do 2019 Majun V3 paper and the question 4A. Okay, let's have a look at that. Let me quickly just find that. So 2019, and then Majun paper 1-3, question 4A. So logic gates he's saying. Okay, logic gates, sometimes they give you some tricky logic gates. But yeah, okay, so I found the question. Let me quickly just take a picture of this. Give me a second. By the time, if you can find some questions, go ahead. Okay, find some questions, tell me, we'll do it together. If you have any particular like problem in something, then we can go for it. But I think the main reason I wanted to do this live stream was for conversions, which I think the thing is resolved. Okay, yeah, okay, yeah. So this is a question on logic gates, and we'll do the first question and then we'll have a look. There's a part B, so we'll have a look at that part B also. So it says consider the given logic circuit. Okay, consider the given logic circuit, and we are supposed to redraw this logic circuit using only 4 logic gates, and each logic gate used must have a maximum of 2 inputs. That means the NOT gate is eliminated because the NOT gate only has 1 input. Okay, so that's already eliminated. So what are the options of gates we have? We have the AND gate, we have the NAND gate, we have the OR gate, we have the NOR gate, we have the XOR gate. We have these options that we have to pick from 1, 2, 3, 4, 5, 6, 7. From 7, we need to make it 4. But let's see. Really easy, because what I've identified is that there's an OR gate and then a NOR gate. Sorry, an OR gate. So a NOR gate and then an OR gate will make it a NOR. So that's one gate we'll need. Then the OR gate again with another OR gate. So we'll need it again. So we'll need another one of this. Then there is an AND gate and then a OR gate, meaning we will need one of the NAND gates. So that means 1, 2, 3, and then XOR gate. Simple as that. Simple as that. Okay, it's as simple as that. So let's draw this. It is as simple as that. Okay, because of the OR gate in front, it will make the entire logic gate become, you know, the NOR gate or whatever, you know. Is that okay? All right, so let's draw this. Now my drawings will be terrible, but just excuse me. Let's see. So we have A, we have B, we have C. So we go A. Let's start off with A. Now this one will be an OR gate. Okay, this one will be an OR gate. And then now we have another one. Now we have another one right here. So this is another OR gate, we said. It is joining to make a NAND gate, wasn't it? And then finally, there's the XOR gate, which is like that. So this is the answer. Is that fine? Okay, I know there's a part B. which I'll just do in the same page right here. Okay. Okay, let's do the part B. So the part B is a table, and this part B, I don't think I need to copy paste it, isn't it? Because it's just the normal. It's telling us to give the truth table of the circuit. So the truth table of this circuit, what if, for example, there were no NOT gates? What would you do that? Now, the reason they've made it so simple is actually because of the reason why they want you to minimize, but it's not really that hard. If you do physics, I believe there's a questions like this. I don't know if you can try to find a paper, right? It will be more easy for me. It will be way more easier for me. If they substituted another gate, the best thing you would do is to actually make the truth table of both the two gates, and then you need to find a gate which gives that the same truth table as the ones that you found. It's the same thing. I hope you get me. You're getting me, right? So you're doing the truth table of the OR gate and then the truth table of something else, and then you need to find a gate or a logic gate that has the same truth table than those two. Okay, that makes sense, I think. Okay, yeah, so let's do the truth table. Truth table shouldn't be really hard. I'm not gonna actually copy paste it, but yeah, so it's, should I copy paste? Yeah, let's do it. Sorry about that. Give me a second. Is it possible? Okay, I'm trying to move this. Give me a second. I'm literally struggling. I'm literally struggling here. Okay, whatever. Let's rub this right here. Literally, bro, this is so. One second. So let's actually scoot it up here. Then let's draw it. Yeah, so you've understood, right? Let's just do the truth table because you've sent this question, Let's do the truth table. Okay, so here we have A, we have B, we have C. So it'd be 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0. They give you this in the question, so don't worry about that. Now my method to this question is first list the question. List the logic gates. So this will be 1, this will be 2, this will be 3, this will be 4. So we'll have 1, 2, 3, 4. Okay, bad drawings, but yeah, allow it. Okay, so 1, let's do 1 is a NOT gate. A NOT gate, or it's a NOR gate. It's such a bad drawing, it looks like a NOT gate, but it's a NOR gate. NOR gate is opposite of OR gate. OR gate is addition, so this will be the opposite. So this will be 1, this will be 1, this will be 0, 0, 0, 0, 0, 0. Let's go to number 2. Number 2 is B and C together. B and C together. It will be again the opposite. Okay, and then number 3 will be a NAND gate of 1 and 2. And it will be the opposite. Okay, finally number 4 is a XOR gate. Like terms are 0, unlike are 1. Okay, so let's see. So we have it's joining with 3 and C. So here will be 0, 3 and C, isn't it? So another 0, then 3 and C. It's going to be 1, 0, 1, 0, 1, 0. I hope that's what the marking scheme says. I'm not looking at the marking scheme right now and doing this paper, but hopefully that should be what it says. But these ones you always double check, because you can always make mistakes. Always you can make mistakes. So hopefully that answers your question. I hope that answers your question. Okay. Yeah, perfect. Has anyone given me another question? Okay, so there's some questions right here. It says, do we need to know about microphones and how they work? Yes, you do. Okay. Now, in terms of how they work, I don't think I've seen a question like that, but the max I've seen for microphone is whether it's input or output, which is really easy. It's input. Okay. Simple. Now, yeah. So that one is a tricky question because many people think it's output, but it's actually input. A microphone is an input. Okay. Some people confuse it with a speaker, but if you know how a microphone works, it basically will send that data into a speaker and then it is projected. But microphone is an input, but you don't need to know how they work. You just need to know whether they're input or output. I think that's, if you can confirm that in the syllabus code, that would be much better. But I have not seen any questions so far talking about the fact that you need to know, how it works. Then there's another question. Can you give an overview on logic gate building blocks using NAND gates? Is it as in, what we just did right now? Isn't that logic gates? Or do you want to know how NAND gates are? I'm not getting your question that well. Okay. But yeah, the logic gates you need to know is the ones I mentioned. You need to know OR gate, NOR gate, AND gate, NAND gate, okay, the XOR gate, right? Okay, so that is what you need to have a look at. Is camera an input or an output? Now remember, okay, so let me tell you how you can classify whether it's an input and output. What does a camera do? A camera takes pictures. A camera takes videos. It is entering into the system, that's why it's an input. Okay, an output will display. Now the camera can have a screen, okay, but that doesn't make the entire camera an output. Okay. But a camera, in most cameras, they are input devices. But if they have a screen, right, if they have a screen, then that makes it an output, isn't it? I hope you're understanding what I'm trying to say. Because to classify what an input device is, data has to be entered into the device. And then output device, it will display that data. Okay, so that's how you can classify it. So a camera takes pictures, hence why an input device. Can you quickly go over SSL and TLS? Don't worry, no problem. Let's quickly go over that. How will I clear all this? Okay, let's just quickly rob it. Okay, why is it not robbing this? Oh yeah, because I locked it, didn't I? Okay, now let's delete it individually. Okay, let's just try to find a way. Now with TLS and SSL, right? With TLS and SSL, the main thing you need to learn is the way they operate. Okay, and usually they are it's like around a 4-mark question. Okay, Zainab, I mean to make OR gate, NOR gate. To make OR gate, NOR gate, NOT gate using NAND gate. Okay, now does it mean like now I need a type of question, because I think you're trying to mean that how we can make from 2 gates we can make 1 gate. Previously what I said was, you look at the truth table. Okay, you write the truth table for both the logic gates, and then you will go and look at which logic gate fits that criteria, or which logic gate does that. But if you have a particular type of question you want me to do, go ahead and put it down. Tom, I've seen your your question. I'll have a look at this just after I discuss about SSL and TLS. Okay. Now, what do you need to know about SSL and TLS? It's quite straightforward, okay? Because first of all, you need to know that this uses certificates. It uses digital certificates, okay? So the full form of SSL, first of all, you need to know is Secure Socket Layer. Now, this SSL uses a digital certificate, okay? And what it does is that SSL is a form of protection, okay? The browser will ask the server to help identify itself or help authenticate itself, and then the server will send them a digital certificate. Then the browser checks whether this digital certificate is authentic or not, and if it is authentic, then the transmission takes place, then a session key is created, and so on so forth. Okay, so on so forth. Okay, that's how it is. Now TLS is almost the same thing as SSL. So if they tell you to describe TLS, you can just describe SSL, you will get the mark. I believe there was the mark scheme allows that, okay? And another thing you need to know about TLS is the fact that it has two types of layers, which is the record layer and the handshake layer, that you need to know. Okay, so yeah, that's the main two differences, and usually they come with 4 marks. So that's the main things you need to have a look at. Okay. TLS is more recent, okay, compared to SSL. You don't need to know that, but just for the sake of it, okay. Yeah, so hopefully that answers your question. Let's do this question right here. Someone has told me to do, okay, October, November 2021. Give me a second. Give me 1 second. Okay, so 2021, right? October, November, variant 3. Again, if you have any doubts, just go, you can list it down below. I'll try my best to answer you. Okay, so you can do past papers along with this live stream. If you have any difficulties in that paper, then you can go over on that. Which question was it? 4A. Okay, so I skipped it. 4A. Okay, I've seen 4A. Let me quickly take a screenshot of this. It's the one about the interrupt, is it? I hope I got the correct question. Right, it should be the correct question. Let me just quickly paste it right here now. So this question is on interrupts. Now you need to know the difference between interrupts and buffers. Okay? And this is managed by the microprocessor or the operating system, actually. The operating system is a better way to put it out. Okay. So here someone has asked me to do this question. And it says that Frederick prints a document that he has typed. Okay. It says a printer begins to print the document, but then a message is displayed on Frederick's computer. Okay. And it says there is a paper jam, okay, which is an interrupt. It then says, describe the role of an interrupt in generating a message on the computer that the paper has jammed. Now, this is easy because, okay, first things you need to know for an interrupt is a signal, and the interrupt is the main purpose of the interrupt, coming from its name, is to interrupt whatever is happening and focus on the problem. If there's a printer jam, you know, whenever you're printing something and there's a paper, like there's maybe a paper jam, okay, the first things first on your computer, they'll say there's a paper jam. That signal right there is called an interrupt. You need to first understand that, okay? So an interrupt is a signal that stops the actions that are currently carried out, okay? Before you even, you know, talk about that. Now, who will generate this interrupt? The printer does. So the printer generates the interrupt, okay? And who serves the interrupt? That's the microprocessor, okay? And they usually say the interrupt is given priority, or is given, more importance, as I previously said. Now, if there are several interrupts, then there is something called interrupt queued, and then the CPU, or the in this case operating system, stops whatever it's doing currently and focus on this. Now, how will it focus? The first thing it will do is give an error message to the user and ask the user to do something. Okay, then this operating system will fix the interrupt and then generate a message, for example. That will give you 4 marks. That will give you way more than 4 marks. Okay, I'm not going to write everything, but hopefully you understand to do it verbally. Okay, so hopefully that will help you understand what interrupt is. Okay, what's a buffer? Now, a buffer, the main difference between a buffer, right, is that an example I can give you is like when we are streaming a video, or for example this video itself. Have you noticed, like on the YouTube, when you're watching a video, there's a gray mark that's always ahead? If you've noticed, it's always ahead of where you actually are. That is called a buffer. A buffer is loading stuff in advance so that you don't get your video doesn't lag. Okay, so it will load the video ahead of time. That is called a buffer. Okay, that is a buffer. It's not a signal, but yeah. Okay, it would be helpful if you go over integrated circuits, and another topic is about calculating file sizes. Yeah, if you are at the start of the stream, yeah, I covered all about file sizes. Okay, so after this stream is out, you can have a look at that. I did three questions about that, and it's almost the same thing. But if I quickly just briefly go over everything once again, main things you need to know for that for the number files, for the file sizes. Sorry. Hi Fatima. For the file sizes, what you need to know is you need to know bits to bytes to kilobytes and then to megabytes. Okay, from bits to bytes, divide by 8. From bytes to kilobytes, divide by 1024 or 1000. Cambridge allows 1000, and then again this. Okay, this is what you need to know. As simple as that. This right here is what you need to know. So first things first, usually they give you about pixels. Okay, you do the pixels, you convert it to pixels, then from pixels to bits. To convert pixels to bits is times 8. You convert those bits into bytes, convert those bytes to whatever they want. If they want in kilobytes, you give kilobytes. If you want in megabytes, you give megabytes. Okay, so that should be that. Some questions are more straightforward. They say there is a 16-bit image, then they give you how many pixels it is. If it's 1000 pixels, so you do 1000 times 16. Okay, and then you divide by 8 if you want in bytes. Okay, so yeah, that is straightforward. I know it's a bit confusing, but it's really easy. The more papers you do, practice makes perfect, right? The more papers you do for this, for the challenging ones, the more easy it will become. So someone has asked me to do October November 2016. That's an old paper. That is an old paper. Hopefully this is in our syllabus, but we are going to do it because I think it's about logic gate theory. I couldn't get you a question. That's good. Okay, so October November 20, is it paper 1 2? Okay, paper 1 2, question 7. Okay. Okay, I got you. Yeah, I got you on the question now. Okay, I got your question. Let's paste this right here. Someone has asked me, so I'm having immense struggle with computer science paper 1. My teacher always marks my answers wrong and I'm so fed up. Can you please help me to find where I can get paper 1 notes? Now, for summary notes, there's Z notes, and the best notes is the textbook. If you've seen my videos, I always use the textbook. I think that textbook is perfect. It has everything that you need to know. Use the textbook. But if you have time constraints, go and look at Z notes. There's a summary, right? That one is quite straightforward. Now, maybe the reason why your teacher is marking you wrong is because you need to understand the marking scheme answers, because these teachers, they just mark the marking scheme answers. Okay, for computer science, you need to know the definition according to the mark scheme. Okay, and that will get you your marks. So maybe you could even revise through past papers, because there is such little time. Do past papers. If you don't know the answer, go over to the mark scheme and memorize the definitions. If it is SSD, memorize how the SSD works. If it's HDD, memorize how the HDD works. Okay, that's how it works. Okay, so if it's logic gates, that's how it does. Okay. Yeah, and there's someone is suggesting a website. Yeah, there is a lot of resources online. Okay, there are many other YouTube channels that also talk about computer science. You can have a look at that. Okay, so here we have a question, and here it is telling us complete the truth table and name the single logic gate that could replace each logic gate. Okay, so let's see how to do this. Okay, so we are supposed to complete this truth table first of all. Okay, let's complete the truth table. Let's complete the truth table. So divide this into two parts. First part is a NAND gate. NAND gate of A and B. So that will be the opposite. Remember, first we do AND gate. Usually for the ones that are opposite gates, do the opposite. Okay, so for AND gate it will be 0, 0, 0, 1. So for NAND gate it will be 1, 1, 0. So I'll write here 1, 1, 1, 0. Then this one right here is another NAND gate. Okay, it is another NAND gate. Right? What's happening in the chat? Okay, yeah, so yeah, so let's just erase this. Yeah, okay, so that's the first part. Then it's saying whenever there's like this, whenever it's like this, okay, every time you see a type of logic gate that happens something like this, right? So what you're supposed to do, okay, is you have to get the inputs from that same, the same one. Okay, meaning it will be the opposite of 1, 1, 0. Okay, I don't know if you understand that. Okay, the NAND gate will be the opposite of this, so it'll be 0, 0, 1. Okay, so meaning this is duplicated twice. So if I do NAND gate of this, it would become 0, 0, 0, 1. Okay, is that fine? Let me explain that again. Whenever the inputs are on the same logic gate, just duplicate them. So the answer here would be 0, 0, 0, 1. Now which single logic gate gives you this from A and B? It's the AND gate, because 0, 0 gives 0, 0, 1 gives 0, 1, 0 gives 0, 1, 1 gives 1. How I remember the AND gate is the multiplication gate. If you don't understand logic gates, I made a long video doing so many past papers, but I call the AND gate the multiplication gate to remember. So this answer is the AND gate. Let's move on to the next one. Okay, let's move on to the next one. So here we have A. Okay, remember, duplicate A to get the NAND gate. So it will be 0. Okay, so AND gate would be this, so NAND gate would be this, 1, 0, 0. Okay, what I mean by duplicating is because both the inputs are coming from the same, so I'll just duplicate A. Okay, and A is this, so just duplicate it. This is for AND gate, this is for NAND gate. AND gate is multiplication gate, so you multiply all this, you'll get this. NAND gate is the opposite of AND gate, you will get this. Okay, same thing here, so it'll be like that. And this is AND gate, this is a NAND gate, sorry. I don't know if I'm talking to myself but it is quite straightforward, isn't it? Okay, so yeah, then we have another NAND gate for this. So you do NAND gate. So first we do AND gate. Okay, so we do AND gate, it will be 1, 1, 0, 0. Then NAND gate is the opposite of AND gate, so it will be 0, 0, 1, 1, which should be the wait, give me a second, 1 second. Think, give me a second. Let's do this again. NAND gate will be the opposite of A, so it will be 1 1 0 0. This one will be, oh, okay, my bad. Do you guys see the mistake right here? Okay, look here. For A, right, it's the duplication of A, so it'll be 0 0 1 1 0 0 1 1. So for the NAND gate, okay, let's first do AND gate, will be 0 0 1 1. So for the NAND gate, it will be opposite of this. Now this is all for A. For B it is different. What I thought it was the same, but it was different, because for this one it will be like this. Okay, let's do for AND gate then. It will be 0 1 0 1, and for NAND gate it will be 1 0 1 0. So we write those two together now. Okay, and then finally NAND gate will be the opposite of this, so hence why the answer will be 0 1 1 1. Yeah, and which gives you this logic gate? Which one gives you this? This would be, let's see, 0 plus 0. Yeah, I think it'll be the OR gate. 0 plus 0 is 0, 0 plus, yeah, it'll be the OR gate. Okay, did you guys understand that? Who asked the question? Good question. Who asked this question? Tom, yes, I hope you understood. Oh wait, was it Tom? I'm not sure. No, it was someone else. Zainab, yes, I hope you understood this. Did you understand? The main trick is to give truth tables and then get the answer. Okay. Syed Ahmed is saying, Maranjan to your teacher recommended notes. Yeah, they are not precise, that's true, but again, for last minute revision, it is good. Okay. The best precise one would be the marking scheme, wouldn't it be? Because that one, you can even revise through the marking scheme. For any subject, that's how you could do it. Okay, for any mark scheme, anything. Yeah, hopefully you understood that. So this thing, remember, this is a tricky one right here. This means you duplicate A. Okay, this means you duplicate A, meaning it'll become 2 of this. Okay, and that's how you structure it. Okay. Yeah, so I believe that is it. I did cover most of the questions. Okay. And I hope this helped. Okay, if you have any questions still after this, there's Instagram. There's any comments? Can you go over 1C? Is this go over IC? What does this mean? Integrated circuit. Is that what you're trying to say? IC as in, do you want to go over do you want to go over von Neumann or what? Because I think what you need to know for integrated circuit, if that's what you want, you need to know about von Neumann. Okay. You need to know about von Neumann. Okay. I don't know if that answers your question. Do you want to go over von Neumann or do I do add math classes? No, I don't. Okay, yes, von Neumann. Okay, so let's go over von Neumann. Von Neumann is not that hard actually. Von Neumann is you just need to remember the steps. Okay, that's the trick. So for von Neumann, you just need to memorize the steps, and I'll give you the steps in just a moment. I will give you the steps in just a second. Okay, just remove this question. Okay, let's go over von Neumann. Von Neumann, you need to know, I think, 7 or 8 steps. First step, okay, I'm just going to go briefly, but the best way, I think, you want to remember von Neumann, you go over the textbook, but this is what a summary is. Okay, PC stores the address. Okay, then address is sent Can you make a video on finding errors in P2? I'll try to, because I think P2 is next week, isn't it? Isn't P2 next week? Yeah, you guys have it next week. Right now you guys have P1 on Friday, so I might do another video for P2 maybe, because many people were asking me for the pseudocode for the one I just did. So I am planning to do something like that, like a similar type of stream. Okay, so we'll do something like that. Okay, it'll depend though. Okay, we'll see. Okay, but let me see. Yes, von Neumann. Okay, yeah, von Neumann. One second, guys. Give me a second. Okay, yeah. So yeah, where was I? Okay, so I was talking about von Neumann. So the PC stores the address. That's the first thing. Now the PC is program counted. The full form is program counted. Okay. The next thing, it is copied to the MAR. And this is done by the address bus. Okay. We have three types of buses. We have the address bus. Okay. We have the data bus. We have the control bus. Okay, let me give you the quick descriptions. The address bus will carry all the signals relating to addresses, meaning stuff you will need later. And the direction for this is unidirectional, okay, meaning only one direction. Data bus is the only one that is bidirectional, okay, and then control bus again is unidirectional. Data bus sends data between the processor and the memory unit, and then of course input and output devices. And control bus carries signals relating to control, okay. Yeah, so then from the MAR, it goes to the MDR. This is done with the data bus. Okay, then the MDR to the CIR. Okay, MDR to the CIR. Now then, the value of the PC is incremented by 1. So PC plus 1, and then instruction is finally decoded and executed. That is the most simplest way I can do von Neumann in. You just need to remember, first thing, PC stores the address, then the address is sent to the MAR to CIR, MAR to MDR, the MDR to CIR by the control bus, and then the PC is incremented by 1, and then the whole process is repeated as it's fetched and executed. Many times they will ask you about the different types of buses. So we have 3 types of buses, and I mentioned all 3 of them. Data bus is the only one that is bidirectional. Can I make a video on the questions? Yeah, many people are asking me to do that, so I'm planning to do that. Okay, but right now let's focus on P1, I think. Okay. Yeah, so I'll make a video on finding errors. Okay. So yeah, is this similar to fetch execute? Yes, it is. Yeah, yes, it is. So you need to know only about fetch execute. That is what the von Neumann diagram. So basically, the von Neumann diagram is a circuit, isn't it? Okay, that fetches and executes. It's a whole process that goes round and round in the computer. And what steps I just talked about is what the von Neumann means. But many people call this. Okay, so what do you guys mean by von Neumann? What exactly about the von Neumann? Okay, because questions that talk about von Neumann, they all come also in this. Okay, I hope you understand it, because even if you go to your past paper, anytime they ask you to describe von Neumann, you are talking about all the address buses. Okay, you're talking about all of this. Okay, but in reality, okay, if you guys are you're saying this is fetch execute, let me tell you what happens in the von Neumann. Von Neumann is not, it's just the broad term. Okay, so what the von Neumann is, I think you know this diagram right here, the fact that there is a memory unit here. Okay, then there is a processor, Then there is output device. All this comes under what happens in the fetch execute. Okay, there's the input here. Then there's the control unit here. Are you guys talking about this? Because the von Neumann, it has the processor, the memory unit, the input output devices. This is called computer architecture. Okay, there was a person called von Neumann who developed this idea of the program. Okay, and within the program, of course, there's fetch and execute that happens. Okay, if they ask you to draw this, then this is what you draw, something like this. You'd get a mark for that, and then you would explain how input output is related to this. But the buses are in this von Neumann. The buses are in the von Neumann. Okay. You should do a topical past paper marathon for P1 today at night. You're saying I do many past papers or what? Maybe. Let's see. I don't know. Right now, I think technically I am doing past papers, aren't I? Because many people are sending me the past papers. Okay, so yeah. Do you want me to do past papers, or just do we call it a day? Okay, so just before we end, okay, if we are, let's see, I'll decide as we go. Okay, let me tell you the topics that you need to know for tomorrow, the important topics, the ones that usually come. Okay, let's have a look at that. First things first, page 1. This is my predictions. Okay, page 1, revise conversions. Okay, conversions. In this we have binary. Okay, we have denary, we have hexadecimal. You need to know how to convert each of the following. Past paper night today. Okay, maybe I don't know. I can actually even maybe continue this live stream to do past papers, just maybe. Okay, let's see. But for now, let's do this. Okay, so page 1 usually is conversions. I think I've seen a trend of conversions. Okay, whereby we have binary to denary to hexadecimal. Okay, then page 2. Now I can't go exactly page by page, but conversions should be there. The probability of conversions being there is maybe 90%, 80%, 90%. Okay, the next thing you need to know, there will be data transmission. Okay, so in data transmission we have serial. Okay, we have parallel. Okay, here you need to know. Okay, let's write here predictions. Okay, I'm not sure actually, but I'm just gonna give a broad term because I'm giving my predictions according to how common topics are. So here we have data transmission, here we have serial parallel. You need to know the definitions of serial, you need to know the definitions of parallel, you need to know the advantages of parallel and serial. Okay, you need to know that. Next thing you need to know is the error methods. You need to look at all error methods. You need to look at checksum, you need to look at ARQ, you need to look at parity bit. Okay, checksum, ARQ, parity bit. What else are there? Check digit. Have a look at these. Okay, check digit, all of this, there are high chances of them coming. Of course, logic gates, again, this topic, there's 90%. Let me show you this one, 90%, this one, 90%. Okay, I'm not giving you any guarantee, so don't say that I'm giving you guarantee. I'm just trying my best to give according to predictions, but there's again no say. So if it doesn't come, don't blame me. Okay, but this is a good way to prepare. Okay, do we have to explain checksum? Yes, you do. I have seen many past papers where they ask you to explain checksum, but checksum and check digit almost the same thing, so yeah, checksum, check digit, you need to know how to explain. If I quickly summarize it, basically calculations are done before the transmission, it is attached to the value, and then the transmission takes place, and then it's recalculated. If the two values are different, then an error has occurred. Next thing you need to know, next thing that might come, sorry, translators. Okay, here we have the interpreter, the compiler, and the assembler. High chances of them coming. Okay, high chances of them coming. You need to know input and output. This is a broad topic, but just memorize printers, scanners, projectors, barcode readers, QR scanner. Also memorize the difference between barcode readers and then the QR code. Okay, you need to know that. So there is a big topic about input and output. Also within conversions, you need to know like the uses of hexadecimal. You need to use the uses of binary, denary. Then within input and output, you need to know about storage devices. So here we have HDD, SSD, we have CDs, we have DVDs, stuff like that. There can also be compression, actually, might come. And this would be, I think, yeah, compressions, I don't know. But you know, compressions only have like one type of question. If you have noticed, compressions are always almost the same type of question. Okay. And do we need to do calculations for checksum and check digit? Now, if you need to do calculations, okay, they usually give you the calculation for, especially for check digit. Okay, for checksum, okay, I've seen in the older papers, right? I've seen in the older papers where they tell you to do the checksum, like the divide by 255, so on and so forth. So memorize that. Maybe. Can you explain von Neumann? I just explained that like just some moments ago. So if you maybe can skip behind, I don't know if you can do that. Playback. I just did that. I did it in brief. Okay. Yeah. MER, MDR, CIR, PC. I talked about that. Yeah. So that's that. Compressions might come, might not come. But if it comes, it will ask you how compression is done. Okay, if it comes, it will ask us how did lossy compression happen, how did lossless compression happen. It's quite straightforward. Then you will have the questions where we have fill in the blanks. That one's really easy. Yeah, then security threats, revise that. You know, at this point I'm literally naming almost all, but you know, there is high chances for most of these questions to come. I think conversions, as in where you have bits, bytes, that might not come. It's really rare, really rare, really rare. Might come though. You know what they say is that what you don't want to come comes, isn't it? So revise everything. I talked about that in the start of the stream, if you are wondering. I did talk about that. Okay, and then next thing, let's talk about this. Next thing. Okay. Yeah. So logic gates could come. Okay. The different types of transmissions and all that. Then microprocessor, the sensor ones, sensors, microprocessor. So these ones are easy, 7 marks. Okay, now let me tell you how to answer this type of question. This type of question, first thing you need to mention, right? First thing you need to mention, right? The first thing you need to mention is, okay, I've stopped. These are the topics that I have predicted. Okay. Yeah, exactly. Just learn everything, but the high chances is logic gates and conversions. And then of course there is input and output. These ones for sure they'll come. Okay. The probability of microprocessor coming, maybe 50%. Okay. Maybe 50%. What do we need to know about HTML for our exam? So first things you need to know for HTML is the full definition of HTML. Hypertext markup language. You need to know HTML, you need to know the structure, you need to know the presentation. Yes, exactly what you're saying. Yeah, basically that's it. You need to give 2 examples of structure, 2 examples of presentation. Okay. Which is the use of HTML, exactly. For sensors, do I need to mention DAC or only ADC? So according to the marking scheme, you only need to know ADC. Okay. Let me tell you how to answer these microprocessor questions. It's really easy actually. This is the guide for answering the microprocessor questions. First things first, say the sensor sends data to microprocessor. Some questions you have to mention which sensor. Okay. Have I explained high level? Lol, I haven't. I can go over that in some time. But first thing you need to know for microprocessor, right, is about the sensors. So it sends data to the microprocessor. You need to mention that. This one usually is 1 mark. Okay. Then the next thing, converts data from analog to digital with ADC. Okay. After that, you can say that the microprocessor compares the criteria with preset values, and if there, then it depends on the question. If it's a question on temperature, it will say you can say if it is greater than this certain type of temperature, then it will send it to something called the actuator, and the actuator will do something. The actuator, what the actuator does is it has moving parts, okay, and it will perform stuff. It's like a robot, okay. That is how it works. Okay, that is how it works. Browsers can also come. Now with browsers, you just need to know the role of a browser, and when looking at marking schemes, it's really inconsistent. Okay, it's really inconsistent because sometimes they mention some stuff in the marking scheme for the same type of question, in different ways. So the safe side is to write as much as you can. That is the safe side. So the more you write, the better. There's no undermarking. So that's one advice I'd give to you. Do we get partial marks for microprocessor question? The way the marking scheme works is that if you have mentioned a point, there you go, 1 mark. If you mention this, you've got a mark. But if you only mention that it's digital data, you will not get a mark. There's no half marks in any subject. Okay. So yeah, that's how it works. Okay. So some people are talking about microprocessors. Yeah, so that's the end. And then always in the end, try to mention that the process is repeated, even if it's a mark in the marking scheme or not. Sometimes they give you a mark for that. Okay, so that's the main idea behind this. Okay, any other topics from this? Right, you need to know checksum, ARQ. Remember, it uses timing signals. Okay, it uses timing signals. Then we have parity bits, really one of the most easiest error methods. Okay, is there any negative marking? There is no, which is the good thing about IGCSE. In any subject, there is no negative marking. So if they ask you to explain the role of the browser, okay, you give all the ones you know. Like I remember in some marking schemes, they say cookies is one of the roles. Okay, cookies is one of the roles, but in other marking schemes I've seen that it's not. So it really depends. Okay, do we write in paragraphs form or note form? Well, you can write in paragraphs. Okay, you can, but like if it asks you to state 4 uses, you can write point form. That's fine. Yeah, but you won't be penalized if you write note form, but you can write in paragraphs. It would be advisable to write in paragraphs, and then full stop, another sentence, full stop, another sentence. Can you do some calculation questions? I have done a couple of them in the start of this stream. Okay, so you can go back there, or if you have a particular question, you can put it down in this comment section right here. Like tell me the year, tell me the question, and I'll do it. But let me repeat it once again. What you need to know is, for the new people right here, you need to know bit to byte to kilobyte, then to megabyte. You need to know from bit to byte, divide by 8, byte to kilobyte, divide by 1024, and then kilobyte to megabyte, divide by 1024. Yes, file calculations. I did several past paper questions in the start. Okay, several of them. So after this live stream ends, we can have a look at that. Let's go over logic gates. Okay, let's go over logic gates, because Logic gates is always tested, so let's focus on the topics that are always tested. Conversions always tested, almost always tested. Okay, there's no guarantee, but there's usually always tested. Logic gates also usually always tested. Okay, and yeah, okay, and file calculations are a really rare topic, but there's possibility it can come. So let's have a look at logic gates. I don't think I've had a look at this. Computer science is easy, guys, don't stress. Okay, you just need to know your theory, that's it. For this paper is really easy, like honestly really easy. Like if you've seen my past paper videos, yeah, I finished them in like 30 minutes. If you've noticed, I know I don't write, but some of the papers I even write and finish them in 30 minutes. Okay, so let's go over logic gates quickly, because this one is almost 90% likely to come. Have you solved the wildlife park tickets? No, I haven't solved that pre-release. I've solved the one where you have to do a survey of people. Okay, but yeah, so let's do logic gates. So there are 6 logic gates you need to know. We have the AND gate, we have the NAND gate. Now I'm drawing this on my computer, so it might not be the best. We have the OR gate. Okay, then we have the NOR gate. Then we have the SOR gate. Then we have the one NOT gate. Yeah, I'm doing logic gates just now. And that's the NOT gate. So these are the logic gates you need to know. Truth table. How do you memorize the truth table? Many people ask me how you memorize it. Easy, because AND gate is a multiplication gate. Okay, this means you multiply the inputs. Okay, NAND gate is the opposite of the AND gate. The OR gate is the addition gate. You can use a pencil. Yeah, use a pencil actually. Don't use pen, because if you make a mistake, then it will become really messy. Use a pencil. Use a dark pencil, but that'll be fine. For logic gates, use a dark pencil. Yeah, CS is really not that big of a deal. Just know your theory, that's it. Okay, that's it really. NOR gate would be opposite of OR gate. Then we have the XOR gate is like is equals to 0, unlike is equals to 1, and this is opposite gate. This is a quick summary of all the logic gates. Okay, this is like a quick summary for logic gates. Guys, you can send me some past paper questions, like the ones that are really hard. Okay, I will be on the stream for quite some time, so okay, I'll just be doing questions that that's there in the comment section. Any topic, just name it. I think I've done almost like 50% of the syllabus just in this live stream. Almost like 50% of the live stream, almost 50% of the syllabus at this point, right? But don't stress for computer science. Just know the theory. Okay, you need to know the definitions of all of the all the main things like browser, HDD, this, that. File calculation, someone is really insisting me. I've done so many questions on file calculations before, but let me try to find some more, like for photos. Yes, I've done many of those. Let me repeat one of them just for the sake of you. let me just repeat one of them for file calculations. They're really not that hard. I think they are really not that hard. Let me just do one of the questions again. Just one question, it's almost the same for all. Okay, let me paste it right here. So here's a file size calculation question, because someone is really insisting this. I've done this previously on this live stream, but don't worry, I'll do it again. So Georgia is a wedding photographer. She wants 10 photographs. Keep in mind, it's 10 photographs, not one. Many people make a mistake on that. It's 10 photographs. And each photograph is 100 pixels wide, 50 pixels high. Okay. And it's saying it is an 8-bit photograph. And then we are supposed to give the answer in kilobytes. That's the key information. So let's do this. Okay, that is the key information. So let's do this. First things first. First step is the pixels. Okay, first steps, pixels. So you multiply the pixels together. You will get 5,000. First step, that's the first step. The next step, okay, next step, convert pixels to bits. Okay, so I will do that 5,000 times 8, which is 40,000. Then, third step, bits to bytes. Okay, which is 40,000 divided by 8, giving 5,000 bytes. Okay. Then, fourth step. Hopefully you guys can still see, right? Fourth step. Let me move it a bit more this side. Okay, fourth step. This is for one photograph, so you multiply for all photographs. Don't forget this step. So 5,000 times 10 gives 50,000. Now this 50,000 is in bytes. We want in kilobytes. So 50,000 divided by 1,000. Okay, so you do this and then the answer would be 50. Cancel out the zeros, answer will be 50. Do we have to make it to bits? No, you don't. But sometimes the marking scheme gives you a mark for that. So maybe if you made a mistake later on, right? If you made a mistake later on, then you won't get the mark. So it's safe to do it. But it is the same thing almost. I talked about it previously, but it is the same thing, right? But just do it because you get a mark for that according to the marking scheme. Like that marking scheme will give you like a mark for that. Hence why I think, you should do it. Advisable to do it. Okay, yeah, someone is going. Yeah, all the best to you. As he says, make flashcards, sorry. And yeah, use pencil for logic circuits. Because you see, if you make a mistake for that, it'll be a big problem. Because you see, to cancel out with pen and then make the whole logic circuit again, that'll be big problems. Yeah. So that is that. What is that? Can I do low level and high level? Let's go for that. Yeah, let's do low level, high level. I haven't done it in the stream. Let's do low level, high level. Okay, someone is asking, hey, I just want to make sure paper 1 is everything in the book except section 2, right? Yeah, that's right. That is right. So it's just a theory. No pre-release, nothing like that. No Python, no flow charts, nothing like that. No sorts of stuff like that. That is all paper 2. Paper 2 is next week. Paper 1, strictly theory. Okay, so we're having a look at low-level languages, high-level languages. Okay, so someone requested this. Okay, low-level languages. Now what you need to know within this, okay, we have 3. Okay, we have the interpreter, we have the compiler, and then we have the assembler. Okay, these are the ones that you have to look at. Okay. And you need to know the differences between each of them. Okay, so let's have a look at the differences between each of them. One second, guys. I just need to sort out this stream. Okay. Give me a second, guys. Okay, yeah, so yeah, let's get back to this. Okay, so interpreter, the differences between each of them. First of all, now the interpreter is an example is Python. Interpreter does line by line. Okay, interpreter does line by line. It is a high level language. These two are high level. This one right here is low level. Okay, what's the difference between high level and low level, you might ask? Now high level is more closer to human language. It is more easier to understand. On the other hand, low level is only understood by the computer. Okay, is only done by the computer. Will you be able to see the stream? Yes, you will. Okay, after this I'll upload it, so don't worry about that. I'll upload this stream after this. Okay, so interpreter and compiler, that is high level. Okay, then assembler is low level. Now what the differences between interpreter and compiler? The interpreter executes line by line. It reads the statement line by line, as Hamid has correctly said. What does the compiler do? The compiler will read the entire code and then, execute it. And for the errors, the interpreter will give, as soon as it detects an error, it will, give an error message. But for the compiler, okay, for the compiler, it is going to first execute everything and then give the error. Okay, so we need to know the differences between interpreter and compiler because they usually come. They are not languages, right? I mean, technically, yeah, they are, but like, you don't say I am doing interpreter language. There are examples of interpreter. Example of interpreter is Python. If you have studied Python, you know this. Python is done, like that. But they are compilers. These all interpreter, compiler, and assembler, they are called translators. Okay. But then when you're talking about high level, you're talking about Python, for example. Okay. Because some of the features about high level language is that it's easier to understand, less prone to make errors, okay, then stuff like that. So you need to know the differences between interpreter, compiler, assembler. Another difference that you need to know is about the executable file. The executable file is only made in the compiler and in the assembler. No executable file is made in the interpreter. So right here, no exe. These two, exe file produced. Okay, so those are the main differences. And then a compiled program is usually distributed for general use. Interpreter is usually for a program, and then assembler is usually again for distribution. Okay. Why does he say it's HLL? Because it is high level language. Yes, interpreter and compiler is high level language, hence why. I don't know if you're understanding the concept. Basically, let me tell you, a compiler is a program. Okay, it's a program that translates a program written in high level language, okay, which is called HLL, okay, into machine code. So all these languages are converted into machine code, and it's done by the interpreter. So the interpreter will translate only high level language. I hope that's more clear. Okay. Interpreter, compiler, and assembler are called translators. Okay. And high level, low level, they are languages. I hope you understood this, Jai Harish. Okay. Suleiman, I have gone over SSL and TLS in the start of the stream. So maybe if you could like play back, I don't know. At one point, I talked about SSL and TLS, but if we quickly just go through it, is SSL uses certificates to check the authenticity of a website. So the browser will ask for the authenticity of that website, and then the web server will send a certificate to show that it is authentic. Okay, so SSL uses certificates to prove if it is authentic or not. Okay, and the browser will check if they are or not, and then that's how the transmission takes place. For TLS, almost similar to SSL, it's more newer. And TLS, you need to know for CIE, you need to know the two different layers, which is handshake layer and record layer. Pretty much that's it. Okay, but if you have a particular type of question, I've done in the stream a question, then yeah, okay, then that is that. Okay. So yeah, I hopefully this confusion is clear, because the interpreter, compiler, and assembler, they are translators, and they translate the language. They translate high level, they translate low level. Assembler only translates low level. Okay, yeah. So, and you're welcome. Yeah. So that is about low level languages, high level languages. Okay, we've gone over logic gates, we've gone over low level languages, high level languages. Fetch, decode, execute, I was talking about it previously, but again, let me go over it just for you. The steps you need to know is PC stores the value, then PC to PC to MDR, then MDR to MAR to CIR, and then the PC is incremented by 1, and the process is repeated. That's fetch execute cycle basically. Then there are 3 buses you need to know for CIE: the address bus, the control bus, the data bus. The address bus will change, will transport the address. Okay, just coming from its name, control bus, it'll carry the signals. Data bus carry data around, and the only bus that is bidirectional is data bus. Okay, this is all under computer architecture. It's a tricky topic though, but for computer architecture you just need to remember the steps. Okay, that's the main thing. Just need to know the steps. You guys also revise cookies. Okay, also revise cookies, because that sometimes many people miss out. Cookies are just packets of information that stores the user's data, so that one you need to have a look at. I'm planning to do past papers now. I think let's just move over to past papers, because I think I've covered almost every topic in the past. I don't know how long we're streaming for, so we want to go over that. Okay, so can you go over how to draw a logic circuit with a problem with text instead of the brackets? Text, as in what text? Like, maybe you give an example of this. Can you go over TLS and SSL? I've gone over it almost like 3 times now. I think if you go, just play back a bit from the live stream, I've talked about TLS and SSL. Okay. Cookies, the main thing you need to know about cookies is that it's packet of information, okay, that just stores the user's information to the browser. Okay, and so that anytime you come back to the browser, it will remember everything. It will remember your details and stuff like that. But then there was also a past paper question, right? There's a past paper question where it asked, why is cookies unsafe? I think it was computer science. It said, why was cookies unsafe? And here you would say that it stores data without someone's permission. It could store personal information, so on, stuff like that. Okay, so that is something that you need to also have a look at. Do we need to learn computer ethics? Yes, you do. So in computer ethics, I think you need to just have a look at the errors. Okay, and I was previously mentioning about the different types of errors. We have 4 or 5 errors, if I remember. Okay, can you go over registers? I feel like I forgot what is this. Now, registers as in, is it the use of a binary, that register? Or do you want me to go over MAR, MDR, those types of stuff? No, because they're different registers. Because there is a register in chapter 1 or something where we talk about how registers are controlled, and then later on in the von Neumann we talk about how, you know, registers like MDR and all work. Yeah. Can you go over capacitive, resistive as well? Okay, yeah, let's go over that first. I haven't talked about that. So we have three types of screens. Okay, we have three types of screens. We have the capacitive. Okay, we have the infrared, and then we have the resistive. Okay, we have these three. Okay, the main things you need to know is the benefits and the drawbacks, and you need to know how they work. Okay, usually these ones, they come in like they usually come in fill in the blanks sometimes there, and sometimes they can also just come as advantages and disadvantages. Okay, binary registers. Okay, I'll have a look at this just after this. Okay, now that one, I've never seen a past paper question on it, trust me. Like, I don't think I've seen any past paper question on it. I've done, you know, almost all past papers, haven't seen any question on registers. I think the textbook, they gave that just because just for the purpose of the uses of binary. But we have registers like CIR, PC, MAR, MDR, which you need to know. Okay, so I'll have a look at that in just some time. But let's have a look at capacitive, infrared, and so on and so forth. Okay, so capacitive, we start off. This one is made up of many layers. I'm gonna write maybe with another color, right? You need to know many layers. Okay, this one is many layers, and it creates electric field. So creates electric field. Okay, that is capacitive. Infrared is heat sensitive. Coming from its name, it's heat sensitive. It uses glass. Okay, and then resistive, upper layer touches bottom layer. Okay, to complete like a circuit. That is resistive. Okay, I can even say to complete circuit. Now I'm just gonna verbally say all the advantages and disadvantages. In 2017 there is one. Okay, so if you can send me the question particularly, that would be helpful. Okay, because I don't really remember. I think it's the one where 1 is on, 0 is off, if I'm not wrong. I think that's what you're talking about, where registers are used in robots to control them around. So if it came in 2017, then you can just put the past paper down below. Okay, now for looking at the advantages, drawbacks, benefits, for capacitive, it is cost effective and the visibility is very good. Okay, it also allows multi-touch, but the drawbacks for capacitive is that it can only use bare fingers. Okay, only bare fingers. I think stylus not used, except maybe if it's more modern. For infrared, this one's the ones we have in our phones. It's the most modern, but it's the most expensive. Okay, it has multi-touch, it has stylus, it has very good durability, so on and so forth. For resistive, the benefit is that it's not expensive, and it's also, you can use gloves, you can use stylus, but the drawback is the visibility is very bad, and also sometimes it does not allow stylus. But the screen visibility is very bad. Like in a sunlight, you wouldn't be able to even see it. Do questions on web address come? Yeah, they do. Usually if they come under, like, maybe they ask you what is the role of a browser. Many times they ask you that, like, what is the role of the browser. And for the mark schemes for role of the browser, sometimes it's really different. Sometimes I think there's a lot of inconsistencies in the marking scheme. If you have noticed, like, the same question in another marking scheme will be different. But yeah, do you know how to a 2D or 3D work? Yeah, you do. I've seen a past paper question The main thing you need to know for 2D, 3D cutters, okay. Okay, cutters. I've never seen a 2D cutter. What's a 2D cutter? Is it just cut? What is a 2D cutter? I know 3D cutters. Is there something like a 2D cutter? I thought you were talking about 3D printers and 2D printers. But a 2D cutter, don't know if I've seen something like that. Okay, yeah, there is 2D cutters, yeah, actually. But maybe 3D cutters, but I've not seen a past paper question like that, actually. Rare, really rare though. But the 3D cutter, the main thing you need to know about that, you need to know about the materials they use, like it uses glass, crystals, metals, polymers, and it uses lasers to cut. Okay, and then what you need to mention for 3D cutter is the XYZ direction, and for 2D cutter I think it's only XY. That's what it meant. Yeah, I got your point. Yeah, there is 2D cutters. Yeah, 3D cutters are there. I think there's also 2D cutters where the plane is only X and Y, if I'm not wrong. It's in the spec. Yeah, then it has to be there. Yeah, 2D. Yeah, there is a 2D cutter actually, because so 3D cutter, it has XYZ plane, and a 2D cutter has only the XY plane. Yeah, makes sense. But yeah, I think you're correct. Yeah, but a really rare question. I haven't seen many questions of that. You see, the input and output, it's endless, right? They can ask you about the camera, they can ask you about the mouse, so you really just need to, that one I think might be like general knowledge a bit, right? Sometimes you can get with it because you can't really predict each, you know. Can you go over LEDs, LCDs, and OLED? OLED is not in the syllabus. I know it's there in the textbook, but there's no question in OLED. You only need to know what is XY. So you see, anytime there's a cutter, let me first answer this, then we'll go over LEDs and LCDs. Anytime there's cutting, there's something called the X-axis, the Y-axis, and then they have the Z-axis, okay, to show the length, the width, and the height. So for cutting, for a 3D object, okay, it will cut the length, it will cut the width, it will cut the height. But for a 2D cutter, remember, it doesn't have height, okay? Hence why it will only cut the X-axis and the Y-axis, or height and width. Okay, that we call them XYZ and then XY. So 3D cutter is three-dimensional, meaning, you know, there's height, width, and also length. So that's why it cuts that. So that's the main thing. There is a question on 2D cutter, but it is a match the following. Yeah, so there is a 2D cutter. The 2D cutter cuts XY, okay? We talked about that. Is there any possibility for a mouse question for 3 to 4 marks? Mouse question. Interesting. So, okay, let me just quickly, briefly describe a mouse, and then we'll go over OLED and QLED and all of that. What you need to know about the mouse, there might be a past paper some time ago, but I don't really remember. What you need to know about mouse is a pointing device. Okay, it is first of all an input device. Maybe, okay, you need to know that. Now we have different types of mouses. We have a mouse that uses a tracker ball. We have a mouse that uses infrared. Okay, you could talk about that. So it depends on the type of mouse. If it uses infrared, you can describe even how a screen works, okay, because it will detect the motion of the mouse and then register it on the computer. That is how infrared works. The tracker ball, of course, that one you use your fingers, and then you move around the device. Okay, that's mainly what you need to know about mouses. Okay, I think even in the textbook it's very brief, if I believe. But you can check the specifications. Okay, you can check the specifications. Okay, so so those are the points. Okay, so the points would be it uses infrared, could use trackable, detects movement through infrared, it is a pointy device, it is an input device, it would replicate what you do with the mouse on the screen, and stuff like that. Okay, Yeah, the length, the breadth, and the dimensions. Exactly, that is for that. Okay, so someone, yeah, let's go over LCDs and so on and so forth. Let's go over all those. Sensors and ADC, do I still have it here? Yeah, here, look, microprocessor. We have talked about sensors and ADC. What you need to mention is mainly the sensor sends data to microprocessor will convert this data with ADC from analog to digital. Then depending on the question, it depends like that. So do rewind. I've done all of this. I've done most of the questions at this point now. I've literally done so many questions. Okay, so I've never seen a camera question, but if it comes up, what should we memorize for a camera? Again, these are, you see, input devices. It could literally ask anything. They can ask you, but the most common ones are projectors, 3D printers, normal inkjet printers, laser printers. Those are the common ones. But for a camera, when talking about a camera, what you can talk about digital cameras, isn't it? And you can talk about the tasks that the microprocessor inside can carry out. Now this is really, there hasn't been any past paper on this, so I don't really know how they can bring this up. But yeah, it's an input device, okay, and it captures pictures, captures video, okay, converts the data into digital. You can talk about stuff like that, okay, but yeah, that's that. I think there is, I've also never seen a camera question, mouse question. If they come, okay, it is matching, okay, so that makes it quite easy, okay. Could you go over projectors? Okay, let me just quickly now go over LCDs, OLEDs, and all that. Okay, so we have LEDs first. Okay, then I'll go over projectors. Projectors simply just uses mirrors to project light, so that light reflects from mirror to mirror and then projects. Okay, in simple terms, but we'll have a look at that in more detail. Oops, I wrote LCB. I mean LCD. LEDs, LCDs. You need to know the differences between LCDs and LEDs. What the difference is, you need to know is mainly LEDs is more modern. First things first, LED is more modern, okay, and LED, it has better brightness, better power consumption. LCDs is literally outdated, it's old. But the only thing that's good about LCDs, if I remember correctly, the only thing that's good about LCDs, I'm trying to remember, is that it has good it does not emit any light because it uses backlight technology. Okay, and the full form of LCD is liquid crystal display. Liquid crystal display. LEDs is light emitting diode, and then for LCDs it has backlit, bad power consumption, stuff like that, bad reliability. This one is good reliability. Let me just zoom out a bit so you guys can see. This one is good reliability. Okay, then there is also LEDs consume less power, they have brighter light, they have better image quality, so on and so forth. Okay, yeah, and LCDs, yeah, LCDs are outdated. Okay, from LCDs we went to LEDs, then LEDs to OLED. Now we also have like QLED and so on and so forth, right? Can you go over printers? Yes, I can. Printers. So we have two types of printers that you need to know, which is the inkjet printer and the laser printer. Okay, so we have the inkjet printer, and then we have the, let me see if I can try to erase all of this at once. Perfect. So we go over printers quickly. MS, a barcode is captured and scanned by a camera or a scanner. Light is reflected back. Yeah, okay, so black squares reflect. Okay, so for a barcode, let me tell you what you need to know. Okay, barcode, what you need to know, are used for alignment. You know, in a barcode, right, sometimes the barcodes, they're like this. Okay, these things right here is for alignment, to put that, you know, that the, what do you call, the machine or the input device, you know, and align it. You know, like in a matrix there is those sorry, it's not called a matrix, it's called the QR code. There's those things like this, the outside boundaries, those are for alignment. And the same thing, it's there in the barcode. For the barcode, what you need to know is, you simply just need to know that it converts to binary. It is the input device, it is the scanner, light is reflected back, the black squares reflect less, the white squares reflect more. Okay, and this right here, I think you might be talking about the QR code. Okay, go over simplex, duplex and stuff. Yeah, I'll go over that. Let me just quickly go over printers. But yeah, simplex is the almost the early chapters, isn't it? Yes, exactly. I think that's the answer for QR code. I think that's why, but it could be also for barcode. You see, these marking schemes are really inconsistent, that's why. And QR, okay, there's a difference between a barcode and a QR. Okay, there is a difference. The difference is that the QR code, it has the alignments, it's more square, it has a matrix, it could be scanned by your phone, you know, while the other ones, it really can't. Okay, that's the two differences. But let's go over printers. So we have two types of printers. We have the inkjet printers and we have the laser printers. Yeah, so we have the two. And in hurry, I type barcode instead of QR. Yeah, it's QR code, no worries. But QR, you see, anytime you see a QR code, there's always those boundaries, if you have noticed. All those boundaries, that is for alignment. If you have ever seen a QR code, which most likely you have. Okay, so that is that. Okay, let's move on. So inkjet and laser. So what do you need to know about these? So laser is the more modern one. Okay, we have also 3D printers, 2D printers. Now the inkjet printers, they have nozzles. Okay, these ones have nozzles. Okay, and it basically uses nozzles to spray. Okay, it's used to spray droplets of ink onto the paper. Okay, and it uses something called piezoelectric technology. You must have heard that in the marking schemes. Okay, it uses something called the piezoelectric technology. This piezoelectric technology simply means what I'm just saying right here. It sprays the droplets and so on and so forth. Okay, yeah, then for the laser, okay, I'm just going, you know, quite brief. And then we have the laser printers, and then I'll have a look at the two differences between the two. The laser printers are more quiet, they're more expensive though, cartridge is more expensive, but they have better quality, better longevity, and they also use dry powder. They use dry powder. That's the difference between the two. Okay, now inkjet is best for one-off photos, laser printer for high quality printouts. Also, laser printers are more quiet, so in places where you need to be quiet, you know, that's where you'd use it. Okay, so those are the differences between the two. Okay, now let's go over, I think there was another question in between somewhere. I had to go over something. Projectors, wasn't it? Yeah, let me go over projectors. Is thermobubble in the syllabus? I haven't seen a question in that, but you need to know what a thermobubble is. Thermobubble is for inkjet printers. Okay, this is basically tiny resistors. Okay, they are very small resistors that make the ink, I believe, makes the ink go away. What is it called? Condense? No, vaporize. Yeah, condense. Okay, and this causes the ink to make bubbles. That's what's called thermal bubble. But I don't think it's in the syllabus, if I recall quite. I don't think it is. If someone wants to see the syllabus, okay, let me actually pull up the syllabus somewhere. Now give me a second. I don't think it's there. I know it's there. You know, sometimes the textbook. Oh yeah, simplex. Oh yeah, I forgot about that. Yeah, okay, let's do that first. Simplex of duplex. That one is okay. So we have, I think, 3 of them. Okay, someone can check the syllabus and check that. But okay, so we have simplex data transmission, we have half duplex data transmission, and then we have full duplex data transmission. What is the difference? Simplex is one bit at a time, and then there's single wire. Half duplex is several bits over several wires. Wait, sorry, okay, this one depends if it's serial simplex or something like that. Okay, and then there's parallel. Now if it's parallel, it's many wires, not single. Okay, so it really depends. But the main thing you need to know about simplex, actually, main thing you need to know about simplex is the fact that simplex is only in one direction. Okay, one direction. Actually, we'll go over several bits later. So this is one direction, this is both directions, but not at the same time. Okay, and then we have this one is both directions, same time. Now if it is serial, then it's single wire. Okay, if it is parallel, it is more than one wire, multiple wires. That's mainly what you need to know. It's as easy as that. Simplex, data travels in one direction only. Okay, yes, the serial and parallel is the confusion. Yes, serial, we are talking about how many wires. So for serial it is single wire, for parallel it is multiple wires. Okay, that's the difference. Simplex, one direction, half duplex, both directions, full duplex, both directions but not at the same time. You need to know maybe some few uses. A use of simplex would be let's see, computer to printer. Is that an example? I don't know. Simplex, we usually don't use simplex at this one. You also need to know the differences between serial and parallel. This differences between serial and parallel. For serial, we use it in long distances, parallel for short distances. The reason we use serial for long distances is because there's less chances for data to be skewed, is what we call them. There's less chances of data being skewed. Is there any other questions, or we can do past papers? I think I've gone over almost every topic. This video is almost like the entire syllabus. It's not even last minute revision at this point. I should change the title to this revision. It's not last minute, because this is more than a minute. It's been 2 hours anyway. Yeah, so I mean, yeah, I was just carried away by many topics. Yeah, because like people just kept giving more topics and topics and topics. Yeah, that's why. So it's no more a last minute revision. Anyway, yeah, so I think we can do past papers now, because not that many people asynchronous. What do you need to know about asynchronous and synchronous? It's basically yeah, you need to know about asynchronous. Do you want to know the meaning of asynchronous? Is that what you're trying to ask? Now, asynchronous data transmission is when there is an agreed bit pattern, asynchronous with the A. Okay, and synchronous only without the A. It is when the data is a continuous stream of data. It's sent one bit at a time. It just keeps sending. Okay, and then asynchronous with the A is a agreed bit pattern. I've talked about projectors. Basically, they use many mirrors. Okay, if I quickly want to go, I quickly talked about them, but projectors use several mirrors and uses light. Okay, so we have light projectors and we have DLP. So these projectors, okay, they output something. They are called output devices, and they use millions of micro mirrors, okay, on a small digital light projector, DLP. Okay, so yeah, so that's the main thing. I think they have many mirrors and light is reflected among each other, and that's how it is projected. Okay, can you go over asymmetric and symmetric and asymmetric encryption? Yeah, I can. Encryption, I haven't gone over encryption. Encryption is when you're converting normal text data into ciphertext. Then we have something called the symmetric and then the asymmetric. We have the two types of encryption. Okay. Okay, so yeah, let's go over that. The two different types of encryption, don't we? Mainly where you need, they usually ask you about, for encryption, they ask you what is encryption. Here, okay, where is half duplex data transmission used other than walkie-talkies? I mean, they usually, let's see. Half duplex is really outdated. That's why they usually no one uses it. Okay, and I think one reason is enough, walkie-talkies. But there's never been a question that has ever asked for the use of half duplex. I believe so. If according to my remembrance, if that's a word, I don't remember. I don't remember seeing any question asking about the uses. Can you do the logic gates question on the 2020 specimen? I'll do that. 1 second. So let me just answer your symmetric and asymmetric question. Okay, so what you have to say is symmetric encryption is a secret key. Okay, it combines many characters, jumbles them up, and it then scrambles it. But the difference between asymmetric then is I believe it's not there in the syllabus. Okay, let me check it up. I think if I remember carefully, you just need to know about the normal encryption thing. So when you're talking about encryption, you need to know about asymmetric just being the risks that surround symmetric encryption. Okay, meaning asymmetric is more secure than symmetric, because asymmetric with the A uses it uses a private key and a public key also, while the other one it's not that safe. That's the main difference between the two. Okay, but again, they usually don't ask that much differences between the two. Okay, let me find this specimen paper that someone is talking about. 2020 specimen paper. Give me a second. Let's do this logic gate that someone is asking me to do. Give me a second. Okay, there you go. Okay, let's see. So this is the specimen, isn't it? Where will I find the specimen? Right here. Okay, specimen. It's which one? Is it the 2020? Okay, let me go to the Cambridge site. Give me a second. So I'm getting this question where I think it's logic gate, a logic gate question. Logic gate, sometimes many people are confused on it. I don't know why. It's a simple one. Not really that hard. Okay, so I found it. Is it Killer 23? Let me mute him. I've seen. Yeah. Okay, I've put him on a user timeout. Okay, yeah, that's not fine. Okay, anyway, let's do this this question right here. Let me copy paste it. Let me paste it right here. Sorry, I'm doing all this alone, that's why. Okay, yeah, let me paste it now. So this is the logic gate question for specimen paper that someone has asked me to do. So let me draw. Is it just drawing the logic gate maybe? I'll draw it on the side, okay? I'll draw it on the side. So it says an alarm S sends a signal when a certain fault conditions in a chemical process are detected. Okay? And it basically is giving us binary values. Anytime there's one, meaning there's no NOT gate. Okay, I'll explain that later on. Just give me a second. Let's do these questions first. So we have A. Okay, well, let me draw it. We have A, T, and we have S. We have to draw the logic gates. Let's start off with this. Draw the logic circuit for the above system using these logic gates. So we can only use these logic gates. Okay, perfect. Let's see. We read this right here and then do the logic gates. Okay, yeah, you know the truth tables. Okay, okay, no problem. Let's only do the drawing. Okay, it first says by saying the temperature is greater than 120 degrees. If it is greater than 100, greater than equal to 120 degrees, meaning it's this. Okay, you got that. 1 second. Yeah, okay. So if it is just greater than 120 degrees, then meaning it's 1, then you just draw a straight arrow here and draw whatever comes next. Okay, and it says AND, so it's an AND gate, and it's joining with stir bar off. So stir bar off will be a NOT gate, and it will join together to form an AND gate. Okay, sorry for the bad diagram. Then it's saying OR. Okay, so it's joining with the OR gate, and it's saying acidity is greater than 5, so it's a 1 value, and temperature is less than 120. Okay, so this okay, then this is joined by an AND gate. I'll explain this 1 second. Let me just quickly draw it. And then this is an OR gate. Okay, so you can see the main thing is here. The main thing you need to understand in this question, okay, is that whenever it's 1, there is no NOT gate. Whenever it's 0, there's a NOT gate. As simple as that. That's the main thing you need to know. Okay, so whenever there is 1, you don't have to draw a NOT gate. Whenever there's 0, you draw the NOT gate. Also, a quick tip is that whenever, if it's 5 marks, for example, okay, then there should be 5 logic gates. So 1, 2, 3, 4, 5. So there are 5 logic gates here. So it would be correct. Okay. It says either. Either is just part of the question. There's no logic gate called either. Okay. Yeah, there's no logic gate called either. Okay. Is Python a good language to learn? Yeah, it is. It's a simplistic, but we don't need that for IGCSE. But yeah. Can an email be considered as simplex data transmission? Email, one direction. I believe you can. Data is being transmitted through the email, but yeah, I believe you can, right? I believe you can. Because serial data transmission is in one direction only, meaning that email is only being sent one way. Maybe you can check it out. Okay. So yeah, it should be, I think, maybe. But the best example for the data transmission is from a computer to the printer, okay, or the computer to a modem or something like that. I think this one would be more risky, I think. Yeah, I don't know. Yeah, I think so. Okay, so we have some other questions right here. It's saying what does it mean when we say the USB is used to send data externally to and from ferrous fields? So you see, USB is a storage device, isn't it? So that means we take in data, we also send in data. Okay, that's what it means. And this one, I think the definition you got in is from the von Neumann, is where we use USB. So to understand USB, remember, it works just like the SSD. It uses NAND technology, uses flash memory, it stores the data, stuff, so on and so forth. It has many transistors, so on and so forth. Yeah. Okay, so that's mainly what you need to know. Why did you end it with an OR? Because look here, you see this OR gate right here, don't miss it out. OR right there, there's an OR gate right here, so don't forget that OR gate. Okay, that's why there's no logic gate called either, so you don't start with either. Yeah. Yeah, when will you go through past paper questions? Yeah, I'm planning to do it right now. Yeah, let me do that right now because I've just answered all the questions. So let's do past paper questions now. Okay, let's do past paper questions. Do you want me to go over? Let's go over the 2021. I don't want to go over Feb March because computer science is the marking scheme really varies with time to time. Okay, that's why maybe I might be wrong in some questions, and that the examiner will only know. Okay, but you still avoid it because if you've noticed, like the questions for the role of a browser, if you've noticed, if you're keen, if you've done many past papers, you know that there are different answers. Okay, let's do a paper that I've never done on this channel. I've done quite a lot of papers on this channel, so, and I don't even remember. I've already gone over von Neumann, yeah, just rewind, exactly. Let's see if I can go over one of these. Let's see which paper. I think let's go over 2020 because I don't think I've done many 2020 papers. I've done quite a lot of 2021 papers. 2020 papers, not that many. So let's find one of these 2020 papers. Let's do one of these October, November 2020 papers. Don't think I've done this. On the channel, don't think I've done it. Okay, let's do this question. Give me a second, guys. Let me copy the link. One second. Yeah, so we're just gonna do some past papers right now. Like we've covered almost all the questions, and many people have you gone over connections? What do you mean by connections? As in, what do you mean by connections? What does it mean when we say that USB is used to send data externally to and I answered that, didn't I? So USB is a storage device. Okay. Internet ethics. I talked a bit about it. But if there's a question on the past paper about internet ethics, we'll have a look at it. Okay? Yeah, you see, there's a question on QR codes right now. That one might come, right, in exam. Then this fill in the blanks, I think it's usually quite general. Fill in the blanks are easy, 3 marks, right? And then yeah, what else? So that's the basics. Then we have the logic gates, truth tables. Should we do this paper? Can you go over freeware share? Okay, yeah, let me go over that first. Freeware, shareware, software. Okay, let me go over this before doing past papers. Yeah, because the main idea of this stream was not actually to do past papers, but then because I have almost done every topic, it's not at this point. It's not even last minute revision. Like I've literally gone over all the topics. But yeah, so let's go over freeware, shareware, and software, free software. Okay, so we have freeware. I have my exam coming on Friday. Yeah, this is the preparation for that. You're at the right place, right? Freeware, we have free software, and then we have shareware. Okay. Logic gates is the easiest markers. Yeah, that's true. Logic gates, but then sometimes in the truth tables, just one small mistake can make a mistake. Can you be faster? Yeah, sorry. Let me do it. See, there's so many questions, like I really have to answer them all if you get it. Yeah, but let me be faster. Okay, so we have freeware, we have free software, we have shareware. Let me quickly go over them. Okay. Okay, so between freeware, free software, shareware. First of all, freeware. free software and shareware. These are, anytime you're making a game, for example, okay, you're making a game or something, if you're making any program, right, we classify them as freeware, shareware, or free software. Anything online has these criterias. Okay, now we can start off with the free software. Now, a free software, the users have freedom to copy the code, run the code, change the code, do anything with the code. It's for free. Okay, just coming from the name. Okay, they can run the software for any legal process they want. They can study the source code, so they can do the source code, they can redistribute. Okay, sorry, let me just click. So they can source code, then they share. Okay, they can change it. They have the freedom to do all of this. Okay, and it's all free of it's free of charge. You don't have to pay also, I believe, and you don't need to seek permission. No permission needed. For freeware, this one it's again free of charge on the internet, but you do not get the source code. No source code. Okay, then it's subject to copyright. Okay, and available on the internet. Okay, and shareware you have to pay. Also for shareware, it's usually registered, then it has copyright, and then it also contains trial, meaning like a free trial sometimes, not free, but maybe, yeah. Okay, so something like that. Paper to revision like this would be really helpful. Yeah, I'll try to. I'll really try to. Okay. I'll try to. Okay. Yeah. Anyway, so yeah, that's the main idea, the main points between this. Hopefully you guys are understanding all of this. Is there any other topic? Let's go over the syllabus. Okay, the syllabus. Okay, when we're going over I don't want to miss anything. Remember, input output devices. Actually, let's conclude this live stream because I really don't want to pause papers. Let me go back to when I actually did. Okay, I didn't do it. Yeah. So yeah, these are, if you missed it out, these are the ones I think will come in the exam. Okay, these are the things I think will come. Conversions, I think the first page usually 90% will come. Okay, there will be data transmission, most likely serial, parallel. There would be different error methods. So in the error methods we have checksum, ARQ, parity bit, check digits, logic gates. It's a free marks, really easy, and usually they always come. Translators, you need to go over compilers, assemblers, all that sorts of stuff. We've had a look at this live stream. I'll be uploading this live stream after this. Okay, so go over all of this. Okay, go over this. I've covered almost all topics, so this live stream was almost like a recap of everything, isn't it? Then we go over all the inputs, outputs. In this exam they could ask literally almost any input output, but usually sometimes it's matching, filling the blanks. You need to go over printers, you need to go over touch screen, the different types of touch screens. I've gone over this throughout this live stream. Go over the different types of compressions and how compressions are done. So we have lossyless and we have lossyless and lossy. Go over how they are converted using the algorithms. And then finally we have sensors, microprocessors, that 7-mark question, which is usually easy. So yeah, with that being said, I will call it a day, and yeah, hopefully you guys learned something. And yeah, so I've been streaming for quite some time. This was supposed to be last minute, and I've been streaming for like so long. But yeah, good luck for your exams. Good luck for all the other exams, and thank you guys for watching. Good luck, everybody. So I'll see you maybe for the paper too. We'll see. Okay, we'll see. So I see you later, and good luck for your exams.